Hello grade 12, here Mr. G, and in this video we are going to be talking and learning about two types of forces. Those are conservative and non-conservative forces. So the first thing we're going to do is to classify forces as conservative and non-conservative. Now, forces can be divided into a conservative and non-conservative. Okay? All forces can be divided in two groups. Those are conservative and non-conservative. Let's start with the conservative forces. Okay, so what is a conservative force? A conservative force is a force for which the work done in moving an object between 2 points is independent on the path taken. So the force that when moving an object, the work done by that force does not depend on the path taken is going to be called a conservative force. It's any force for which the work done in moving an object between 2 points is independent on the path taken. And some examples are gravitational force, the other example is elastic force, and another example is electrostatic force. So those are examples of conservative forces. However, we are going to focus only on gravitational force. So all those are examples of conservative forces, but we are going to focus and we are going to work only with gravitational force as the conservative force. So out of all those forces we mentioned as an example of a conservative force, only gravitational force we're going to be dealing with. And then how do we calculate the work done by this force? The work done by the conservative forces is going to be equal to minus change in potential energy. And because we only working with gravitational force, as we said before, the only force is going to be gravitation, so is the gravitational potential energy. This conservative can be substituted with just WC, work done by the conservative forces, and that is equal to minus change in potential energy, minus change in gravitational potential energy, because it's the only force we're doing. Remember, in grade 10 you learn about potential energy. Remember, gravitational potential energy is equal to the product of mass multiplied by acceleration due to gravity multiplied by height. That was done in grade 10. So if we substitute this formula there, we have that the work done by the conservative force is equal to minus there, bracket, mass, acceleration, final height, minus mass, acceleration due to gravity, initial height. This is how to calculate the work done by the conservative forces. This is the way that we are going to use to calculate the work done by the conservative forces. So, recalling what we said here, conservative force is a force for which the work done in moving an object between 2 points is independent on the path taken. This is very important word. We are going to see now when we go to the next definition. Is independent on the path taken, the work done. Work done is independent on the path taken. Examples: gravitational force, elastic force, electrostatic force. However, we are going to focus on gravitational force, and the work done by the conservative forces is equal to minus change in potential energy, and we can work out that formula. Okay, so let's now go to the forces that are to be non-conservative. So, what is a non-conservative force? It's a force for which the work done in moving an object between 2 points depend on the path taken. Let's delete this between because we didn't highlight it in the previous definition. The non-conservative force is the force for which the work done in moving an object between 2 points depends on the path taken. And as I said before, this word is different in the both definition. The conservative forces, the work done in moving an object is independent, and in the non-conservative forces, the work done in moving an object depends on the path taken. Okay? What does it mean? In the conservative forces, the work done by that force is independent in what way is the object moving, in what direction is moving. If it's taking certain path, but in the non-conservative forces, the work done by that force depend on the path taken. Okay? Now, what are examples of non-conservative forces? Now, the examples are frictional force, air resistance, tension force. So those are examples. I'm not going to mention all the non-conservative forces. Those are just some examples: frictional force, air resistance, tension. Okay? Now, those are examples of the non-conservative forces. So how can we calculate the work done by the non-conservative forces? And please note, this is a very important law. The work done by the non-conservative forces is going to be equal to the change in kinetic energy plus the change in potential energy. This is a very, very important law. Is a law of conservation of energy. This is the law of conservation of energy. This is the one that says that energy cannot be created, nor destroyed, but only changed from one type to another. That is this law. Okay? So it is very important. Now, as we did before, we are going to make sure that W non-conservative, and we are just going to leave it with WNC for non-conservative. Is the same formula. I just taking short of the word kinetic energy plus change in potential energy. Okay, so this is the law. Now here you can go on as we did before, and remember the kinetic energy was done in grade 10 as well as the potential energy, and kinetic energy is equal to half the product of mass multiplied by the speed of the object to the power 2. This is kinetic energy, the energy an object has due to its motion. And here we can break down a little bit further that law, but you only break it if you need it. So the work done by the non-conservative forces is equal to a bracket half mass multiplied by final speed square minus half mass multiplied by the initial speed square plus, and now it's changing potential energy. We already did it before here when we work about the conservative forces, so I'm not going to just explain. It's going to go very fast. Final height minus mass acceleration initial height. So this one here is the law. Is the same formula, just now broken into a little bit more formula. It's the same law. So this is everything you should know about the conservative and non-conservative forces. A quick recall: conservative forces are forces for which the work done in moving an object is independent on the path taken, and the non-conservative forces, the work done in moving an object between 2 points, depends on the path taken. The examples of conservative forces could be a gravitational force, elastic force, electrostatic force. We are going to focus only with gravitational force. Example of non-conservative forces are frictional force, air resistance, tension. And here is the way of calculating each of them. I'm not going to go through the formulas again. You can always watch the video, you can pause the video, and that is the advantage of having a video. So you can write comments, you can ask questions, you can suggest, and if you think the video helps, please thumb up. Thank you for watching and good luck.